Okay. So let's see this question. We draw the diagram. So when you're done drawing, let me know so I can give you the statement that follows.
I'm done. I'm done too. I'm done.
Okay. A particle P starts from rest at the point A. A particle P starts from rest at the point A and travels in a straight line, comma, coming to rest again after 10 seconds. Coming to rest again after 10 seconds. Full stop. The velocity graph, the velocity time graph for P consists of two straight line segments as shown in the diagram. Consists of two straight line segments as shown in the diagram. Full stop. A particle Q start from rest at A at the same instant as P. A particle Q starts from rest at A at the same instant as P and travels along the same straight line as P and travels along the same straight line as P. Full stop. The velocity of Q is given by V equals 3t minus 0.3 t raised to power 2 for 0 less or equal to t less or equal to 10. So let me read everything again so that if you miss anything out. A particle P starts from rest at the point A and travels in a straight line, coming to rest again after 10 seconds. Full stop. The velocity time graph for P consists of two straight line segments, as shown in the diagram. Full stop. A particle Q starts from rest at A at the same instant as P and travels along the same straight line as P. The velocity of Q is given by V equals 3t minus 0.3t squared for 0 less than t less than 10. The displacement from A of P and Q are the same when t equals 10. What does that mean? The displacement from A of P and Q are the same when t equals 10. What does that mean? That means they are in the same position. Is that clear?
Yes, sir.
Okay.
Yes, sir.
Question A, show that the greatest velocity of P during the motion is 10 meters per second. B, find the value of T in the interval 0 less than T less than 5, for which the acceleration of Q is the same as the acceleration of P. So let me see your attempt. Do you have an idea so that I won't waste time, please?
I have an idea.
Okay, tell us. Okay, should I allow you to attempt?
Yes, sir.
Okay.
Yes, sir. So I've gotten an answer for greatest speed of E.
Yeah.
Yes, sir. So I've shown it.
So you're able to get 10.
Yes, sir.
So what did you do?
So I took velocity to be ds dt. So I integrated I integrated p is equals to 3t minus 0.3t squared
Okay.
to get the distance.
The
Then
displacement.
to get the displacement.
Okay.
Then I took the area of the graph to be equals to the displacement. Then I got area of the triangle from 0 to 10
Okay.
and equate it to the distance.
Very good. Now, why do you use that? Because in the question, hope every one of you is listening. The last sentence there before question A says the displacements from A of P and Q are the same. So on that premise, I'm free to use the velocity the velocity function of Q given to us, which is VQ, I want to call it VQ now, equals 3t minus 0.3 t squared. And you know that speed is, or velocity is ds dt, but our s this time is regarded as displacement. So this implies that ds dt equals 3t minus 0.3 t squared. So ds equals 3t minus 0.3 t squared dt. So integrate both sides. Integral of ds equals integral of 3t minus 0.3 t squared dt. So s equals, if you integrate the right-hand side, you get 3 over 2 t squared minus 0.3 over 3 t cubed plus c, constant of integration. So both of them start the journey from rest, isn't it? So at
Yes.
t equals 0, s is 0. So that implies that c will also be 0. If you substitute 0 for t and s, so c is 0. Therefore, s equals 3 over 2t squared minus 0.3 over 3 t raised to power 3. So that's the displacement. Now, displacement equals area under velocity time graph. Now, let me go back to the diagram. So this is the highest speed there, or this velocity, if you want to say. Let's call it V. So the area now, half base times height. Hope I'm communicating.
Yes, 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 sir.
3 over 2 t squared minus 0.3 over 3t cubed equals half base. What's the base? The base is 0 to 10. Hope I'm communicating.
Yes, sir. Yes, sir.
0 to 10. And the height is the dashed line, the altitude, which we have called V. 0 to V, that's the height. So base is 10 minus 0. Height is V minus 0. Now, I decided to write it this way because you may see another question that will not start from origin, or the question will tell you from a particular time that will constitute the base. Do you understand that now? So the diagram should be your guide. So when, according to the question, when t equals 10, show that the greatest velocity of P during its motion is 10 meters per second. So when t equals 10, because that's the final time spent to get back to rest. So if you substitute 10 for t here, 3 over 2, 10 squared, 0.3 over 3, 10 raised to power 3 equals 1 over 2 times 10 V. So please simplify that. You must get 10 V equal to 10 meters per second. So that's A. So Jason and Abolaji, write that quickly.
I'm done.
Okay.
I'm done.
So question B say we should find what? We should find the value of t in the interval 0 to 5, for which the acceleration of q is the same as the acceleration of p. What's acceleration? dv dt. Okay. So that means we will now differentiate the velocity function given to us. That's d dt of 3t minus 0.3 t raised to power 3. I mean raised to power 2. So tell me the derivative of that.
3 minus 0.6 t.
3 minus 0.6 t. Very good. So that's the acceleration. So what's the next thing?
We get the acceleration of.
So what's the acceleration of p? The graph, sorry, this is acceleration of q. Let me put a sub q here. This is acceleration of q. Now, go back to the graph. Where is acceleration of p? Because the graph given to us here is for p. Hope you remember. So this is acceleration of p. This slope here, this side, that's acceleration of p. Hope I'm communicating.
Yes, sir.
So
Yes, sir.
we now need to find the gradient of that. From the graph, that will be change in what? In v. Am I right? AP equals v minus 0 over 5 minus 0. And we have found v to be 10. Is that correct?
Yes, sir. Yes, sir.
From question A. So this will be 2. So acceleration of p is 2 meters per square second. Now, the question now says that acceleration of q equals acceleration of p. So that means 3 minus 0.60 equals 2. So 0.60 equals 1. So t will be 1 over 0.6. So that will be what? With your calculator, please.
1.667.
1.667. So let's do 1.67 in 3 secant figure seconds. Hope that is clear.
Yes, sir. Yes, sir.
Okay. So when you are done copying that, let me know.
Sample.
Okay.
So I'm done.
Okay.
I'm coming.
Where are you going?
No, I want to. I'm almost done right now.
Okay.
I'm done.
All right. So let's do another one. Example 3 now. A particle is projected vertically upwards from a point Q. Sorry, point O. From a point O with Initial speed 12.5 meters per second. At the same instant, another particle is released from rest. At a point 10 meters vertically above O. Find the height above O at which the particles meet. Are you making progress? I want to believe you are done writing the question.
Yes. Yes, yes, sir.
So let's have the diagram. You know, I've told you it's important you always sketch. It's very, very important. So a particle is projected vertically upwards from a point O. So let's assume we have horizontal base here. So this is O. So you have the particle projected here, upward. We are told that at the same instant, another one is projected downward. This one is coming down. So let's call this one the distance covered by this. Let S1 be distance moved upward. Then S2 be distance moved downward. And T be the time where they meet. Am I communicating? So as this one moves upward, it will cover certain distance S1. Now from the question says that, what was it again? Where did I say? And now at the same instant, another particle is released from rest at a point 10 meters vertically above O. So what does that mean? It means that the distance from here to this place, the total distance here, is 10 meters. So let's say this is S2, cover certain distance. This is S1, cover certain distance. And they will meet at a particular point T here. Hope I'm communicating. So that's what you want to do. So we started by introducing equations of motion. S equals U plus, UT plus half AT squared. UT plus half AT squared. So what are the parameters that we know? What are the parameters that we know? From the question, we are given initial speed. Initial speed, U equals 12.5. I'm putting it there because the question says a particle is projected vertically upwards from a point O with initial speed. Hope that is clear. Yeah. But here, maybe I should call this one for upward. Here, this one is projected downward from rest. Here, U is 0. Hope you are getting that. Because the question says at the same instant, another particle is released from rest. I want to call your attention to these mechanics. You read between the lines and interpret. That's how to make headway there. So for upward movement, so we are going to have S1 equals 12.5 T plus, now, this one is moving up. This is vertical motion. Remember the formula that we started with, equation of motion. I gave you horizontal straight line and vertical motion. Is that not it? So in this case, because it's moving up, we are going to use acceleration due to gravity. So this will become G. let me say ut plus or minus half gt squared. So because it's moving up now, it's moving against the gravity, we take g to be minus 10. So this will be minus times t squared. Does that make sense to you? So
Yes,
S1 equals 12.5t minus 5t squared, equation 1. Now S2, that's for downward movement. So S2, we said that will cover distance S2. So S2 equals U, this time is 0 times t. Now this one is moving down. So it's moving in favor of gravity. So it's going to be plus 1 over 2 10t squared. So S2 will be 5t squared, equation 2. The total distance expected to be covered by each of them if they would not hit one another is what?
10 meters.
God bless you. So equation 1 plus equation 2. Equation 1 plus equation 2. So S1 plus S2 equals 10. So that will now be 12.5t minus 5t squared plus 5t squared equals 10. This, we take care of this. So 12.5t equals 10. So t equals 10 over 12.5. So that will be what?
0.8.
0.8 seconds. T equals 0.8 seconds. So that's the time they will meet.
Sorry, sir. So is why we're taking S1 plus S equals to 10.
Yes, I said if they will not hit one another, what's the total distance they are supposed to cover? Each of them. The one that is going up. Do you understand that now?
Yes.
So the one that is going up from O should get to the top of the height, which is 10. The one that is coming down should get to the top, the bottom of the height, which is also 10. Is that clear?
Yes, sir.
So reason for taking S1 plus S2 equals 10. And don't forget that they are going to meet at a particular point. So the one that is going up must have covered certain distance. The one that is coming down must have covered certain distance. The total distance expected is 10. So if you have the distance covered by the one that is going up, so the one that is coming down should give us 10. And that's why I use the illustration that what if they are not meeting? They are not going to collide. You know we are not considering collision here. Do you get that now?
Yes,
sir. The
Yes.
meeting at a particular point does not necessarily mean that they are colliding. Hope that is clear.
Yes, sir.
Now, have we answered the question?
No, sir.
Very good. We have only find the time at which they will meet. So the question says we should find the height above O at which the particles meet. So what will we now do now? Since we know the time they will meet, we now substitute that time into your equation 1 and equation 2, or either of them. So if you substitute it in equation 1, what will you get? If you substitute it in equation 2, what will you get? Let me say S1 of 0.8. So that will be what? 12.5 times 0.8 minus 5 times 0.8 squared. So simplify this for me. 6.8. 6.8 meters. Yes, correct. Now, that's the height above O. If we use S2, are we going to get the same thing? Let's check. That's 5 times 0.8 squared. 3 point what? 3.2. So that means the one that is projected upward has covered substantial distance. Can you see that now? Has covered substantial distance before meeting with the one that is coming down. But if you look at that question ordinarily, you will want to make some assumption that may not be true. In the sense that the object that is coming down, coming in favor of gravity, you expect that one to move faster, isn't it? But you can see from this calculation now, it's not so. Okay, that's fine. So let's move on to another one. This one, I'm not going to interfere. It's going to be your work and your work only. Number 4. Question A. A man walks in a straight line from A to B with constant acceleration. With constant acceleration 0.004 meters per square second. His speed at A is 1.8 meters per second. And his speed at B is 2.2 meters per second. So 2.2 meters per second. Full stop. Sorry, please. Let me take So 2.2 meters per second. Full stop there. So the question now says, find the time taken. Find the time taken for the man to walk from A to B and find the distance AB. When you're done writing that, let me know so that I can give question B.
Done.
Okay.
So I'm done.
Okay. Mr. Abukun.
So I'm done.
Okay. So question B. Question B says a woman cyclist leaves A at the same instant as the man. She starts from rest and travels in a straight line to B. Reaching B at the same instant as the man. At time t seconds, after leaving A, the cyclist speed is K into 200t minus t squared meters per second. Where K is a constant. Find Roman figure 1. The value of K. Roman figure 2. the cyclist speed at B. When you are done, let me know.
I'm done. I'm done.
Okay.
So I'm done.
Okay. Question C. Who said A? Jason. Lazy boy. Sketch. Using the same axis. Sketch using the same axis. The velocity time graph the velocity time graphs for the man's motion and the woman's motion from A to B. So when you're done, let me know.
I'm done. I'm done. I'm done.
That's your assignment. If you like, do it. If you like, don't. I will pray for you.
Thank you, sir.
All right. See you tomorrow.
Yes, sir.